Okay, I just wanted to show you now that you can actually analyze an exponential function just like we analyze polynomial and rational functions. So let's start with y equals x squared e to the 5x. Now we're going to need derivatives. So to get the first derivative, I'm actually going to use the product rule. So I'm going to take x squared times the derivative of e to the 5x. Now the derivative of e to the 5x is actually e to the 5x times 5, because 5 is the derivative of e to the 5x. So there's your first term in the product rule. Then the second term, I'm going to take the derivative of x squared, which is 2x, and then multiply it by this function, e to the 5x. Okay, so those are my two terms. Now I'm going to go ahead and factor out of here. Let's see, I have in the first term here, I can factor an x out, the first term and the second term, and also in both terms I have e to the 5x. So let's factor x e to the 5x out, and then if I factor x e to the 5x out here, I'm left with 5x, and if I factor x e to the 5x out of this, I'm left with just 2. So I'm going to write it like that. Now, in order for me to get the second derivative, I have to take the derivative of this. So let's treat this as a product where x e to the 5x is the first term and 5x plus 2 is the second term, factor. So the first factor is x e to the 5x. Well, let's start out with the easy part. Let's go ahead and bring down the first factor, x e to the 5x, and then multiply by the derivative of the second factor, 5x plus 2. The derivative of 5x plus 2 is just 5. Then I'm going to bring down the second factor, 5x plus 2. And now I've got to take the derivative of this, but this is a product. So to take the derivative of this, I've got to use the product rule. So using the product rule, I'm going to take x times the derivative of e to the 5x. And so that's going to give me x times 5e to the 5x. And I just wrote it in this order. So then I'm going to take the second function, which is e to the 5x, and then which is this, and I'm going to multiply it by the derivative of x, which of course is 1. So I just get e to the 5x. Now the rest of this is just algebra. This times this is just 5x e to the 5x. And then here, when I FOIL, if you take 5x times 5x e to the 5x, you're actually going to get 25x squared e to the 5x. And then if I do the outer terms, 5x times e to the 5x, I get 5x e to the 5x. And if I do the inner terms, 2 times 5x e to the 5x, I get 10x e to the 5x. And if I multiply the last terms, 2 times e to the 5x is 2e to the 5x. Well, then if you take a look at these three terms, 5x e to the 5x, 5x e to the 5x, and 10x e to the 5x, you can combine them because they're like terms and get 20x e to the 5x. And then I wrote the squared term here, and then the other term was 2e to the 5x. Well, then I'm going to go ahead and factor out e to the 5x. Each of these has a factor of e to the 5x, so let's factor that out. So finally I get e to the 5x times this trinomial, 25x squared plus 20x plus 2. Okay, now we know the derivative, the first derivative is x e to the 5x times 5x plus 2. And I'm going to trust that you can set these three factors equal to 0 and solve. If you set x equal to 0, you're just going to get x equals 0. If you set 5x plus 2 equal to 0 and solve it, you're going to get x equal negative 2/5. Now remember, if you set e to the 5x equal to 0, you're not going to get an answer because e to the 5x cannot equal 0. You can't raise e to a power and get 0. So the only critical numbers are 0 and negative 2/5. Now you need to test the intervals to determine where the function is increasing and decreasing. So let me set that up for you and I'll show you. Okay, so I just did a kind of a crude table here for you. Negative 2/5 and 0 are the critical numbers, so I got a test number to the left of negative 2/5. I'm going to use negative 1. Now if you go back over here and plug negative 1 into this, you'll find that your answer is going to be positive. Now, I chose negative 1/5. I needed a number between negative 2/5 and 0. I just chose negative 1/5. Well, if you plug negative 1/5 into this and evaluate it, you're going to get a negative value. And then I chose a number greater than 0, which is 1. And if I plug 1 into this derivative, I'm going to get a positive value. Well, since the derivative is positive to the left of negative 2/5 and to the right of 0, then those intervals, the function must be increasing. And since the derivative is negative between negative 2/5 and 0, then the function is going to be decreasing on the interval negative 2/5 to 0. And then from the first derivative test, we know that we're going to get a maximum at negative 2/5. So f of negative 2/5 is a maximum, and I got 4 over 25e squared by plugging negative 2/5 back up here into the original function. And that's the exact value of the maximum. Now the minimum is a little bit easier because 0, using the first derivative test, I see that 0 is going to give me a minimum, and plugging 0 into the function up there is pretty simple. You'll just get 0 squared times 1, which is 0. So there's our extrema. Now the next thing I'm going to do is I'm going to look at the second derivative and set it equal to 0 to see if I can find any inflection points. Well, remember, e to the 5x cannot equal 0. But this trinomial can equal 0, and the way we have to solve it, since it doesn't factor, is we have to use the quadratic formula. So, use the quadratic formula with a equal 25, b equal 20, and c equal 2. And then once you solve it, you should get minus 2 plus or minus the square root of 2 over 5. Well, minus 2 minus the square root of 2 over 5, I wanted to get approximations so I can do my testing. So minus 2 minus the square root of 2 over 5, I used my little calculator and I got about negative 0.7. And then minus 2 plus the square root of 2 over 5, my calculator said that's about negative 0.1. So let me set up a table for that, and I'll show you how I tested for concavity. Now, I used negative 0.7 and negative 0.1, but make sure you understand those are approximations. The actual exact values are over here in the radical form. Okay, so I picked a number to the left of negative 0.7, which is negative 1, and I plugged it into the second derivative, and I got a positive value. So that tells me that since the second derivative is positive, the graph is concave up in that interval. And then when I picked a number between negative 0.7, negative 0.1, negative 0.2, and plugged that in, I got a negative, so the graph must be concave down in that interval. And then I just chose 0 since that's a number to the right of negative 0.1, and so I've got positive, so we're concave up in this interval. So actually the outer two intervals, which, if you want to be exact, is negative infinity to negative 2 minus square root of 2 over 5, and then the other outer interval is minus 2 plus square root of 2 over 5 out to positive infinity. The graph is concave up, and the graph is concave down on the middle interval, which goes from negative 2 minus square root of 2 to negative 2 plus square root of 2 over 5. And now the points of inflection, I'm not going to make you go in and find these values, but the points of inflection, since the concavity changed here, then you're going to get a point of inflection at that point, which the x value is minus 2 minus square root of 2 over 5. And for the y value, I just went ahead and just said the y value is just f of that value. And then for the point of inflection over here, that point, negative 0.1, represents negative 2 plus square root of 2 over 5, and the y value would just be the function evaluated at that value. So we'll just let the y value slide on that. And now, if you put all that together, you can actually get a graph. So let's take a look at the graph. When I first graphed it, I looked at this, and I really couldn't see what was going on. That's because we've got a bunch of small values. So let me show you right here. This point here, or somewhere a point right in here, is your relative extreme at relative max, and then this point here is your relative minimum. So if you remember, my relative max actually occurred at whatever this number is, 4 over 25e squared. It's a very small number, but I've got the graph blown up. So it's right there. And then the relative mean occurred at the point 0, 0, which is right here. Now I put that little X there to show you that we get a point of inflection right there. And so we get a point of inflection. Let's see, we actually get 2 points of inflection. So there must be another one over here somewhere. Okay, so let's see if at negative 0.7, yeah. So somewhere around negative 0.7, so it's concave up here, then it switches to concave down, and then it switches back to concave up. So actually I kind of left off that point of inflection. So those points of inflections are the points where negative 2 minus square root of 2 over 5 and negative 2 plus square root of 2 over 5 are. And so that's where the concavity changes. And so there's your graph. Okay, take this function here, x e to the x, it's not as nasty as the one I just did, and go through and identify what you can here. So do this as a practice problem. And if you need to, freeze the video, then take this problem, identify things like the domain, the intercepts, asymptotes, and then get your first derivative, get your second derivative, and use those to determine relative extrema and points of inflection, and then try to use the information to determine the graph. Also, decreasing and increasing, concave up, concave down. So if you put all that together, you should be able to graph this. So use this as a practice problem and see if you can get the information that I got. Now this function, to get the derivative of y with respect to x, you're going to have to use implicit differentiation. So let me show you how I did that. Remember, with implicit, you apply d over dx to each term. So here I'm going to apply d over dx to each term, and then when I take the derivative of e to the xy with respect to x, I'm going to get, using the rule for e to the u, I'm going to get e to the xy, then times the derivative of xy. And then when I take the derivative of x squared, I'm just going to get 2x. And then when I take the derivative of y squared, remember I got to use the general power rule here and say 2y times y prime. And then the derivative of 10 is 0. Now I still have to finish this. I have to use the product rule on this. So the derivative of this is xy prime and times y times the derivative of x, which is y times 1. Okay, so now I'm at this step here. Now what you're going to have to do is you're going to multiply e to the xy through these two terms, and I get e to the xy prime plus e to the xyy. Now notice that I have a y prime in this first term and a y prime in this last term. So I want to keep those two terms together. Okay, and then what I'm going to do, I skipped a step here, but what I'm going to do is I'm going to move these two terms to the other side. And they're going to change signs. So that's where these two terms came from. Now, when I keep these two terms together, remember that allows me to factor y prime out. So if I factor y prime out, I get x e to the xy. And then if I factor y prime out of here, I get minus 2y. And then finally, if I divide both sides by this expression to isolate y prime, this is my final answer. Okay, so there's the derivative. If you want to see the graph, I graphed it on Desmos, but there's the graph if you want to see it. Okay, I got about a minute here left, so I'm going to show you this one, how I solved this one, and then I'll just freeze it on the next one. Okay, so this, we're given a demand function. I'm going to go a little quick here. We're given a demand function, and so to find the rate of change of the demand function, we need the derivative. So to find the derivative of that, I'm going to get 350 times e to the u, which is negative 0.01x, then times the derivative of u. And then I just simplified it a little bit here, and I got this. And then I'm going to evaluate it at 800 to get the answer for the first question. And then the second one says that we want to maximize revenue. Well, revenue, remember, is xp. So what I have to do is I have to multiply that. So show that this is the derivative that you get for xp, and then set the derivative equal to 0 to get your answer. And then freeze, for the next problem, just freeze the video here and take a look. Bye-bye.